guys, this is Mrs. Robinson, and I'm here to kind of prep and go over with you this upcoming lab that you're going to be doing using some special equipment. It's called CPO equipment, it's the name of the company, but it's a physics equipment that you're going to be using. So I'm going to kind of pre-lab the setup and the parts and the pieces and the jobs that you're doing so that you have a feel for this, so that when you come into class you've already seen it and you'll be able to kind of start the lab and get moving in that aspect. You'll be getting in a lab sheet, of course, when you come to class, and the title of this lab is about force and acceleration. It's actually very similar to your time on the line lab that you did, in which you were testing the effect of gravity on the spool. In this case, though, our ramp is not inclined, it's going to be horizontal, and that's purposeful. When you come into lab, you're going to see a lot of equipment, so maybe come look at the equipment a little bit. You have what's called here is a stand, and it's got a blue column with a triangle base. You might need to kind of adjust it and make sure it's tight, just FYI on that. We have what's here is a ramp, which is actually got values and increments here to match kind of a meter stick, so you've got centimeters here as well. So this is our ramp. You're going to have a tub of equipment, so I'm going to go through that and the particular jobs that go along with that. So this is your setup. So when you come into lab, you're going to leave lab like this as well in terms of putting everything back into the tub. The ramp should be pulled in so that people can pass nice and easily, and everything's good to go. We're also trying to understand forces and how they change motion. And when you change how something is moving, either its speed, by either increasing its speed or slowing it down, that's acceleration. Or even changing a direction, that's still acceleration. So we're understanding forces. It's actually even very similar to what you did with the marbles, the straw, or maybe you guys did a tennis ball, where you applied a force to an object and you saw how you could change its motion by slowing it down or speeding it up, and even having it stop after the inertia. The particular jobs that you're going to have. Persons A, B, C, D, kind of based on your lab tables. Person A is ultimately in charge of the car. They're the release person, and I'm going to kind of go through what that looks like in just a minute. They're the ones to touch the car. They've got the technique, and that's going to, we're trying to keep things constant. B will be the photo gate person. You don't know what this is yet, but I'm going to show you what. But it's basically a very accurate way of getting a time reference. One of you, person C, will be the recorder timer person, so you're in charge of a piece of equipment that shows you a time. And then one of you is in charge of kind of keeping up with the clay, the force that's actually being applied, and I'm going to show you what that looks like. If you have a fifth person, which some of you may, then you can just divide up the recorder and timer positions that way. So those are the jobs officially. When you come to class to get your lab ready, you're going to go ahead and take your ramp and stand. You're going to pull it all the way out. The textbooks, there should be 2 science books at the end of the table. You're going to actually position the ramp on the end of the textbooks. And there's actually kind of a bolt system right here. You don't want that bolt touching on the books because that's going to affect the levelness of the ramp. To test the levelness, we've got some levels you may kind of put on the top of your ramp, and to see that the ramp is nice and level. Okay, so far we've got our ramp set up like this. The car person is going to be in charge of the car. It looks like this. It's got a bolt and a wing nut. It's got a string attached. It's kind of a plastic type string, and that's purposeful actually. Oh, actually, no, it's not. It's not purposeful. Then there's actually a wing, what we refer to as a wing. It's kind of this big stick out part, and it's labeled with an arrow. And that's the piece that's actually going to break through the photo gate beam and actually get to be the time that's read. So the bolt is actually going to go into there's an opening on the ramp. Get it in the ramp, and it's going to be positioned all the way to the back. So this is the car person's job. They're the person that actually touches the car. They release the car. We're trying to control for different variables. So this is the car, and this string will actually lay across a pulley system down here at the end of the ramp. Okay, so far like this. The clay person is going to be manipulating the clay, or in charge of the clay. I shouldn't say manipulating the clay. They're in charge of the clay, and the clay is actually going to just be squished around, so to speak, or kind of adhered down to the bottom of the string. So you just squish it around, a little ball. Okay, and so the string actually kind of goes over the pulley, something like this. You want to have your clay right below the pulley to start with, and everything should be, not rocking and moving. This is basically the setup at this point. We still have to get our photo gate on and look at the timer piece as well. Okay, so I'm going to go ahead and let this stay here for just a minute. The photo gate, now you've got electrical cords, you've got to be near an outlet, so keep that in mind when you're moving things around. Be very careful and kind of delicate with this equipment. If you pull on these, or if you pull on the pieces on this end, it's going to not be good and we'll be very sad, all of us. So this is the photo gate. It's got a clamp system so that you can put it on the actual ramp. There's a beam here that when an object travels through this beam, it reads a very accurate, detailed time. So this is kind of what this looks like. You can play around with this to see if you can increase your time. Here's the timer. There is a little side switch button, so this is person C. You turn this on. You've got a couple lights that show up. Basically, you want to have the first green light on the bottom. It's called the interval. And light A, and then maybe a reset. So you know it's working if it turns on and it says CPO. That's the name of the equipment. It comes on, and then it turns on, and you do a reset, and you should have a 0, and hopefully that means it's up and running. So that when you place your object through the beam, you get an accurate reading in time that's out to the 4 decimals or 4 places behind the decimal. So you're going to take your photo gate, and your directions are going to tell you to place it along different places along the ramp. Okay, so you're going to want to make sure, like maybe if it has you start at 80, you position it right on the 80 increment. And then your car is going to be set back here all the way to the back. This is the car person, the only person to touch and release the car. And so you're taking a time at 80 centimeters, 70 centimeters, 60 centimeters, and so forth. And you're going to allow the car to travel through the beam. So I'm going to reset right here. So right now I'm going to go ahead and release.
Carlos Martinez, please come to the main office. Carlos Martinez, please come to the main office.
Okay, so just to give you kind of a feel of what this is going to look like. Everybody's ready, everybody's set up, and we release. And now you have a time on your timer piece that you're going to record in your data table. And that's at 80 centimeters. You're going to do the same thing for 70 centimeters and so forth. You're going to get a time reading, and that's going to go into your data table. All right, I think that kind of gets you going for the first part of this. So to be thinking about what the purpose of the clay is, be thinking about how you're doing things and trying to keep all your variables constant. Pay attention to when things happen. So you're making observations too as you go, and you're trying to understand how this whole system is working. What's the purpose of the clay? What's the car doing? What happens when the clay hits the bottom? What's the car doing? So be thinking about the reason you're doing some of the things that what you're doing. And I think I'm going to go ahead and stop us there. And so tomorrow when you come in class, you'll have a feel for how the equipment should be set up, and then you and your teacher will go back over kind of the procedures and make sure you know what you're doing from there. See ya.